Stop scrolling, because what you're about to hear could change the way you see Mars forever. Scientists have now confirmed that Mars did not just have temporary water, it sustained it for millions of years. Inside Gale crater, evidence shows stable lakes, chemical energy sources, and mineral layers formed under conditions that, on Earth, are perfect for preserving microbial life. This was not a random puddle. This was a long-lived environment. And it gets even more serious. The rover Curiosity detected organic molecules locked inside ancient rock. Not contamination, not speculation. Verified carbon-based chemistry preserved for nearly 3 billion years. Then came something even more unsettling. Seasonal methane fluctuations. On Earth, methane is strongly linked to biological activity. On Mars, the pattern repeats. And now, Perseverance is collecting physical samples, sealing them in titanium tubes, preparing them to be brought back to Earth for the most advanced laboratory analysis ever attempted on extraterrestrial rock. Before we go further, don't forget to like this video, share it with fellow space enthusiasts, and subscribe to All About Mars Surface to stay updated with every new discovery. This is no longer about, was there water? The real question is far bigger. Did life ever begin there? And if it did, are we ready for that answer? Tonight, we go deeper into the discoveries inside Gale crater, the evidence hidden within sedimentary layers, and the chemical signals that refuse to stay silent. Welcome to All About Mars Surface, where we don't just talk about Mars, we investigate it. Because what you're about to see is not just another Mars update. It might be the beginning of the biggest discovery in human history. Let's begin. At this desolate stretch of Mars, the mission continues. Perseverance carries forward the investigation first pioneered by Curiosity, methodically scanning the terrain for traces of an ancient biological story hidden beneath the dust. Its articulated robotic arm extends with surgical accuracy, studying the reddish soil for chemical whispers of a world that may once have supported life. Subtle dark streaks cut across the landscape, hinting at a distinct mineral makeup, likely basalt forged during Mars' more violent volcanic era. The exposed rock faces reveal stacked layers, each one preserving a segment of planetary memory. These strata are not random formations. They are records, millions of years compressed into stone. Long before this region became barren, it rested beneath flowing water, forming part of a vast lake system that endured for immense spans of time. Perseverance moves deliberately on 6 rugged wheels, each nearly half a meter wide, engineered to maintain stability across fractured ground and shifting regolith. Broken, angular fragments blanket the surface, remnants of larger formations gradually dismantled by erosion and relentless exposure to a thin atmosphere only about 1% as dense as Earth's. The fine-grained regolith tells a quiet story of ancient streams and wind-driven transformation. These sediment deposits imply a lake that persisted long enough to create a potentially habitable setting. Sunlight pierces the dusty sky, casting a harsh glare across the crater floor. Unlike solar-powered systems, Curiosity relies on a radioisotope thermoelectric generator, a compact nuclear power source that ensures steady energy regardless of dust or darkness. Dark dunes and ridgelines stretch toward the horizon, sculpted by billions of years of geological forces. The Martian sky above appears muted and hazy, its pale yellow tint caused by microscopic dust particles scattering sunlight differently than Earth's atmosphere. At the base of a layered outcrop rests a cluster of darker stones. Among them, a circular depression stands out, an unusual feature that demands closer examination. Since 2006, the Mars Reconnaissance Orbiter has circled overhead, delivering detailed imagery that maps formations like these across vast expanses of crater terrain. Scattered nearby are sharp-edged rocks whose angular shapes indicate minimal transport, suggesting localized breakdown rather than long-distance movement. From orbit, Mars presents itself as a rust-colored sphere, its surface stained by iron oxides that dominate its composition. One lighter-toned patch attracts attention due to its distinctive texture and coloration. Perseverance's mast, equipped with powerful zoom capability, isolates such anomalies for deeper study in the search for ancient habitability. Wind erosion is clearly evident here, and perhaps, in the distant past, Flowing water also shaped these features. The rocks in this region consist largely of basalt, confirming a time when intense volcanic processes dominated early Martian history. As imaging resolution improves, the internal structure of the lighter patch becomes clearer. Its surface appears coarser than initially assumed, possibly due to varied grain sizes or prolonged weathering. Pulling back reveals this feature within the broader geological context. The surrounding rock layers extend outward, displaying larger structural patterns. Polygonal cracking etched into the surface suggests repeated wet-dry cycles, a powerful indicator that liquid water once interacted with this terrain. SuperCam captures another perspective, adding chemical data to the visual record. Each rock examined represents a fragment of a planetary timeline shaped over billions of years. Gale crater, spanning approximately 54 kilometers across near the Martian equator, serves as a geological archive formed nearly 3 billion years ago. Curiosity has already traversed more than 28 kilometers within this crater, analyzing basaltic terrain and sedimentary deposits alike. Using laser-induced breakdown spectroscopy, the rover can determine a rock's chemical composition from a distance, revealing elemental signatures without physical contact. The loose regolith continues to shift under persistent Martian winds, a mixture of dust and fractured rock particles molded by erosive forces. Each of Curiosity's 6 aluminum wheels, roughly 50 centimeters in diameter, is reinforced with tread patterns designed for traction on steep and uneven slopes. For nearly a minute and a half, instruments remain fixed on a fractured surface, patterns that excite geologists seeking clues to Mars' environmental past. The rover advances slowly, scanning methodically for anomalies worth further study. The regolith here reflects typical Gale crater composition, fine sediments interspersed with larger broken fragments beneath a fragile, dust-laden atmosphere. One circular cavity stands out distinctly. Such voids can form when soluble minerals dissolve, a possible signature of past water interaction and a compelling target for continued investigation. Here, the Perseverance rover continues the search begun by Curiosity. Its robotic arm, a precision instrument, examines the Martian surface, seeking evidence of past life in these reddish soils. The dark tones suggest a different mineral composition, perhaps basalt. Its layered structure represents millions of years of Martian history, each layer a different chapter in the planet's evolution. This area was once underwater, part of an ancient lake system. The rover's 6 treaded wheels, each 50 centimeters across, navigate this terrain with careful precision. Angular rock fragments litter the surface of larger rocks broken down over time. This granular regolith is evidence of erosion shaped by ancient streams and a thin atmosphere, just 1% of Earth's. These sedimentary layers suggest a long-lived lake potentially existing for millions of years' habitable environment. Sunlight filters through the thin Martian atmosphere, creating a bright, music glare. This light powers Curiosity, not through solar panels, but a radioisotope thermoelectric generator essential for its mission. The dark dunes and ridges, the complex geological processes that have shaped this over billions of years. Martian sky appears hazy, a result of fine dust particles suspended in the atmosphere. Inside Gale crater, every new layer climbed by Curiosity represents a shift in ancient climate. The rover is not just moving forward across the surface, it is ascending through time itself. Higher elevations reveal something critical. The mineral composition begins to change. Lower strata contain clay minerals formed in relatively neutral water, conditions considered favorable for microbial life. But as Curiosity climbs, sulfates become more common. Sulfates form in more acidic and evaporative environments. This transition tells a powerful story. Mars did not lose its water suddenly. It dried gradually. Lake levels fell. Water chemistry shifted. Habitability narrowed. Yet even in these harsher layers, Curiosity has detected organic molecules preserved within ancient rock. These are complex carbon-based compounds, not proof of life, but proof that the raw chemistry for life persisted longer than once believed. Meanwhile, far from Gale crater, Perseverance operates inside Jezero crater, a site chosen specifically because orbital imagery revealed a preserved river delta. A delta is not random terrain. It forms where flowing water slows and deposits sediment, an ideal environment for trapping and preserving biological material. Perseverance has already confirmed that Jezero once hosted a lake fed by an ancient river system. Layered sediment within the delta shows clear signs of water transport and deposition. Even more compelling, certain rock samples collected by Perseverance contain fine-grained mudstone. On Earth, mudstone is exceptionally good at preserving microscopic fossils. But Perseverance is doing something Curiosity cannot. It is collecting samples. And now, the question is yours. If Mars once had rivers, lakes, and the chemistry required for life, what truly ended its habitable era? Was it climate collapse, atmospheric loss, or something far more complex? Inside Gale crater and beyond, the evidence continues to grow. But every answer uncovers new mysteries. What do you think? Could ancient microbial life have once survived beneath the Martian sky? Or are we still misreading the signals locked inside those rocks? Tell us your thoughts in the comments below. Your perspective might shape the next discussion. If you found this exploration fascinating, don't forget to like the video. It helps this mission reach more explorers like you. Share it with someone who's obsessed with space mysteries. And if you're new here, subscribe now to All About Mars Surface, where we dive beyond the surface of Mars and into the science, the secrets, and the unanswered questions that could redefine our understanding of life in the universe. In our next episode, we explore something even more ambitious: the plan to bring Martian samples back to Earth and what scientists hope to find inside them. Until then, keep looking up, because the next discovery might already be waiting beneath the dust of another world. This is All About Mars Surface, and the search continues.